Now, you're probably aware that when you look into a mirror, you are looking at a reflection of the light waves that have traveled from you to the mirror and back to your eyes. You are looking at an image of yourself in that mirror. You appear to be behind that plane mirror. However, if someone were to go stand behind that mirror, they would not find you where you appear to be. You're just seeing an image of yourself in the mirror. To start out, we really need to define what a plane mirror is. A plane mirror is a very thin, flat piece of glass that is coated on one side with a highly reflective metallic coating. So take the light rays that are reflecting off of the bottle in the diagram. Those light rays travel to the mirror and are reflected to your eye. Now your eye receives the light rays and transfers the rays into electrical signals that can be sent to the brain. Your brain interprets these signals as if the light rays were traveling in a straight pathway. Essentially, your brain thinks that the light is coming directly from the object, and so it forms an image of the bottle that appears to be behind the plane mirror. Because the image forms in a place where the object is not, we refer to this as a virtual image. Now, it is important to note that the dashed lines in the diagram are not actual light rays. Those rays do not travel through the mirror. So if we were to put a screen behind the mirror, the image would not appear on the screen. That is one way in which we can define an image. If it cannot be projected onto a screen, then it is considered a virtual image. When analyzing an image formed from light rays, it is important to define a couple terms. First is the object distance. This is the horizontal distance the object is located from the mirror. Similarly, the horizontal distance the image is located from the mirror is known as the image distance. Let's focus in on the ray coming from the bottom of the bottle. The ray strikes the mirror at some incidence angle that we will label theta I. According to the law of reflection, the angle the ray reflects is equal to the angle it came in. Since our mirror is flat, we can draw a right triangle that includes the angle of incidence and the object distance. We can do the same thing on the other side of the mirror with the image. A little bit of basic geometry tells us that since they share a side and the top two angles are the same, then the image distance must be the same as the object distance. This same geometry allows us to introduce the idea of the object and image height, and they too are equal. This brings us to a really interesting question. If you want to be able to see all of you in a mirror, how tall must the mirror be? If the lady in the mirror is 160 centimeters tall, we can assume that her eyes are about 10 centimeters below the top of her head. For her to see her entire body, light rays from her foot must reflect to her eyes, and light rays from the top of her head must also reflect to her eyes. Now we know that the image distance behind a plane mirror is the same as the distance the object is in front. So all we really need to do is show one ray leaving her foot and one ray leaving the top of her head and use a little bit of geometry. Consider the ray that leaves her foot. The ray reflects off the mirror at the same angle it came in and travels to the eye. This is the lowest point the mirror needs to be in order for the light to hit it and be reflected to her eyes. As we saw before, these two angles can form two congruent triangles. Since the two angles are equal, then the height from the bottom of the mirror to her eyes needs to be half the total distance from her eyes to her feet. She is 160 centimeters tall, with the eyes 10 centimeters below the top of her head, so the bottom height of the mirror needs to be 75 centimeters. We can do the same thing above her eyes so that she can see the top of her head. The top edge of the mirror only needs to reach halfway between the top of her head and her eyes, or in this case, 5 centimeters. So if the bottom of the mirror is placed 75 centimeters above the floor, it needs to only have a vertical height of 80 centimeters for the lady to be able to see her entire body. So the question now is, does it matter how far away from the mirror she stands? I will let you try that with your own mirror. Seriously, try it. It's pretty interesting.